that by now you are curious about what's an EPD, how to interpret environmental product declarations. So, Laurent, the stage is yours.
Thank you, Michelle. So I will start here maybe by asking a rhetorical question. So what is an EPD? So in a nutshell, an EPD documents the environmental footprint of a product. But before we go in details of what an EPD actually documents and how does it document it, we will first ask a simple question: why do we need EPDs? So we will start with a very quick summary of what are CO2 equivalent or CO2 e-scopes, as this will come later into play when explaining where the EPD emissions are accounted. The definition of scopes has been done by the Greenhouse Gas Protocol, an NGO business partnership, and it is today used by almost all large corporations in the world, including Siemens. Greenhouse gases not only include CO2, but also other gases, as you can see here on the top of the graph, such as methane or SF6. As per this definition, the scope 1 of a company will be all its direct emissions. For instance, its emissions coming from its own energy supply, its gas heating, its SF6 losses, etc. The scope 2 will account for all CO2e emission linked to the purchase of energy, and the scope 3 will be split in two: one part upstream, notably including the supply chain emissions, so the emissions of all the suppliers, and one part downstream, which will notably account for all emissions of the product of the company when used by its customers. Now, let's see an important aspect of why EPDs also become more and more important. So here, as you can see on the graph, on the slide, we have draft climate disclosures, guidelines from the EU Commission, from the SEC in the US, and from the accounting system IFRS. And all these disclosure guidelines will make mandatory for corporations the reporting of CO2e emissions for scopes 1 and 2, and in many cases also for scope 3. So many companies already report their scopes, but this will become a general requirement in the future. So we will come to the utility of EPDs for the reporting of scopes later in the webinar. Finally, manufacturers and customers may also benefit from EPDs. Manufacturers, in order to issue an EPD, will need to have an internal quantitative assessment of the environmental impact of their product, called a life cycle assessment. And this will bring quite a lot of learnings from where the CO2e emissions of a product come from. And therefore, this will give opportunities to us to consider them in the next redesign of the product. And we believe that as sustainability becomes more and more a topic for corporations, we need as Siemens to provide our customers with the information they will need. For customers, the use of an EPD will be discussed during the webinar. We see here a statement from a third-party certification agency website. So this statement is that EPDs provide a basis for comparison of products, and we will explain our view on this statement later. So now, to start the understanding of what an EPD is, we will show the three different types of EPDs. So this is a type 1 EPD, which will not be a focus of this webinar. And this type 1 EPD is basically a third-party certification that your product can use an environmental label for marketing purposes. And this is mostly for B2C business and household products. The type 2 EPD is a self-declaration from the manufacturer. So the EPD must follow the ISO 14021, but does not mandatorily require having an LCA. The ISO 14021 mandates that the claim must be careful, not misleading, clear, and specific. So Siemens uses extensively type 2 EPDs for its products, and in addition to following the ISO standard, we decided to do an LCA for each EPD we create, following the required ISOs 14040 and 14044, which are standards for the LCA. This is the same requirement to be followed to publish a Type 3 EPD, therefore offering the same transparency in our Type 2 EPDs of what you would get from a Type 3 EPD. So one of the first things to realize when reading an EPD is that the product that the EPD documents will almost always not be the exact version of the product you are buying, but will be a member of a family of products called an HPF. We will explain what an HPF is a bit later in the webinar. But it is important to note that because the product is not the same, the emissions also won't be exactly the same as the product you will purchase. And this is true, not only for an EPD type 2, but also for last type of EPD on the list, the type 3 EPDs. So the type 3 EPDs are third-party certified. You need to follow the ISO 14025 standard, and your LCA needs to follow the ISO 14040 and 14044 standards I mentioned before. The process is that you will need to do your LCA according to a set of rules defined by the EPD system, and a verification agency will verify that your LCA has followed these rules and that you cover in your calculation all the necessary input, that the data sources of your input into the calculation are properly documented, and so on. So now, there are a few things that I would like to highlight about EPD certification. The first thing is that there are many EPD systems around the world. Unfortunately, not all systems recognize each other today, meaning that an EPD done in one system may not be accepted by another system. So this puts a burden on manufacturers. Our LCAs and EPDs are a time-consuming exercise. The second topic I'd like to highlight is that EPD systems may use different set of rules for conducting an LCA, meaning that the EPD results of the same product may differ from one system to another, which obviously is not ideal. And finally, the verification of your LCA doesn't mean that your final emissions figure is correct. It just means that you have followed the proper process and have documented your input and calculation. We have a lot of data input in an LCA, and not every single data input is verified, which is absolutely normal, as the certification only refers to the process that has been followed to do the assessment and calculate the impact. So I realize I may sound negative about EPDs and their use here, but I would like to leave this slide with a note that EPDs are the only documentation available today for a product environmental footprint, and that I believe we are still at the beginning of the journey when talking about EPDs. There are initiatives such as the Product Eco-Footprint or the PEF from the EU Commission or from the International Electrotechnical Commission or IEC to improve the standardization of the assumptions made inside an EPD. Currently in Siemens, the preferred type of communicating to customers, consumers, and other parties about our products' environmental performance is an EPD type 2, always including a life cycle assessment according to the mentioned standards. So we have chosen this approach because it guarantees a high degree of flexibility from our side by ensuring also compliance with the applicable international rules and regulations while incorporating the latest knowledge and technologies from our side. Now, let's move to the topic of life cycle assessment or LCAs. So an LCA is an internal and confidential document from the manufacturer, and the LCA results will be then summarized in the EPD. Here you can see the 5 phases of an LCA according to the ISO norm, and we as Siemens follow this process. So you need to start by setting the goal and scope of the assessment study. So in short, selecting the product you will assess, and as mentioned, this decision already will have some impact on the final results of the EPD, as the emissions will depend on the product configuration you choose for the evaluation. The scope will indicate which part of the life cycle you decide to document. So you have LCAs, for instance, for cradle to gate, which stops the documentation of the footprint at the gate of the factory, or for cradle to grave, which will also include the operation and end-of-life impacts, or for cradle to cradle, which will also include the recycling portion of the product. Then we do a life cycle inventory where we will document every environmental impact throughout the life cycle scope of the product. Here we're really facing a difficult task. So we may have a very large number of suppliers for one product, and we need to account for the CO2e emissions of every single component in the bill of materials, down to the screws and nuts. Additionally, we need to account for the manufacturing process, including, for instance, every minute on the assembly line. So as you can imagine, this is not an easy task. So we also make assumptions on several criteria here, and as these assumptions are not standardized across manufacturers and certification agencies, you may obtain different results depending on the assumptions you make. And now I would like to explain more in details two concepts I mentioned before. The first one is the product category rules, or PCR. So this document lists down the rules under which the LCA should be done. One example of non-standardization having an impact on the results of the footprint is the lifetime of the equipment. So our products will have, for instance, resistive losses during the lifetime of the equipment. So we are making assumptions on the load under which the equipment operates, on the source of energy, and on the number of years the equipment will operate to calculate the emissions. So some PCRs will fix a lifetime of 20 years, while others, like the one from Siemens, will use 40 years, doubling the emissions in the second case. So PCRs have a strong impact on the final emissions documented for the product. The next concept is the one of homogeneous product families, or HPF. So what it means is that when we do an EPD, we will use a certain configuration of a product or a certain product, and that the results of the EPD can be extrapolated to other members of the family. So there are certain rules to be applied when creating an HPF, such as making sure that all the members of the family have similar functionality. So for instance, you will not put a bus bar instead of a low voltage switchgear HPF. They should also use similar materials, but this is still allowing manufacturers to limit the number of EPDs they do. So for instance, our electrical products business has tens of thousands of different final products, and it would be impossible to have an EPD for each one of them. So this is logical that we are allowed to do this. But as extrapolation rules are not well defined, it also means that the emissions of the product you'll buy can be only approximated with the emissions of the representative product of the same HPF for which we have an EPD. So I will now hand over the presentation to Karthik, which will go in a Siemens EPD and explain in details what you can get from the document. So Karthik, over to you.
Thank you very much, Laurent, for such a detailed explanation about EPDs basics. Good morning, good afternoon, good evening. Also from my side, I'm Karthik Reddy Venna, Product Lifecycle Manager for Primary Gas Insulated Switchgear and Sustainability Topics, and also a key expert for switching applications. So I believe you have now some idea about EPDs and how it is created and its background. In the coming slide, I will explain how to interpret a Siemens EPD when you get your hands on one of our product EPDs. In Siemens, we are creating EPDs for all the portfolio elements like air insulated switchgear, gas insulated switchgear, protection equipment, and so on. And I will take today one of our NX+C gas insulated switchgear EPD as an example for my whole explanation throughout this presentation. As I mentioned in the title page, you will see for which representative product the EPD is created. And here you will see which type of EPD it is. As Laurent mentioned, Siemens is currently creating a Type 2 EPD, including a detailed life cycle assessment. In the product information page, a general overview of all the standards like ISO 14021, which is the reference for the creating Type 2 EPDs, ISO 14040 or 44, which is the basis for the detailed life cycle assessment, which is included in this EPD. And the standard EN 50693 is considered as a reference for the product category rules that have been implied in this life cycle assessment. And this shows that even though Siemens EPDs are self-declared Type 2 EPDs, they are prepared based on various international standards and follow similar processes and process steps with the same stringent requirements of a Type 3 EPD. In the product section, you will get the relevant information of the product on which the LCA is made and EPD is created. Here in this case, it's, as I mentioned, it's a NX+C SF6 gas insulated switchgear, which is applied in the primary distribution networks. The ratings and the type of the typical is also given in this section. For example, here we used in circuit breaker typical. And in this section of the material composition, you get a rough overview of the materials and the percentage of it used in the product. This information also serves as a basis to estimate the percentage of the recyclability of the product after reaching its end of the life. Under life cycle stages and the reference scenario section, it is highlighted 3 different stages considered in the life cycle assessment. Laurent has just explained these stages already, along with the definition of what is a cradle to gate and what is a cradle to grave. However, it is important to understand the reference scenarios under each stage as well. For example, in which location the switchgear is manufactured and which kind of electricity is used there. So, for example, in this case for NX+C switchgear, which is manufactured in our Frankfurt factory, where only green electricity is used. This means there is no CO2 footprint that is contributed due to the energy used to manufacture the switchgear. Then coming to the transportation of the raw materials to the factory and its relevant impact is calculated according to the EN 50693 standard. Similarly, under the operation stage, the same explanation applies. For reference, we use the EU 28 grid mix, where different proportions of renewable and non-renewable electricity is used. And this we use when we do not get any information from the customer. With respect to the switchgear itself, the reference lifetime is used as 40 years, load rate as 35%, and assumed SF6 leakage as 0.1% annum is considered, which is according to the standard IEC 62271-320, which is at the moment currently under the draft stage. So one important point I want to mention here is the given SF6 leakage percent is based on IEC 62271 standard, but in reality the leakage percentage will be a lot lower than that is given here. And the distribution of the switchgear from the factory to installation is part of the operation stage, and the same EN standard is also considered here for the transportation. And the same logic also applies for the end of the life stage. So, considering all these before mentioned scenarios, the life cycle assessment is made. In Siemens, we use the Gabi professional tool. It is an LCA tool. And in this section, you will see the list of 16 key environmental parameters that will be impacted by the switchgear throughout its life. And these 16 indicators are listed according to the EN 50693 standard. But just for your info, these are the focus categories as of today, which means they will be updated as per the new standards that is coming in the future. However, in the coming section, I will explain more detail about the global warming potential, because that is one of the most focus points for the customers today. So, in this page of the global warming potential, you will get a detailed picture on the CO2 emissions caused by the switchgear in 3 stages, like from manufacturing till the end of life, and which elements contribute how much of CO2 emissions. Now the question is, how can a user use this data to see or to understand which scope each CO2 emissions will fall under? And this I will show right now. For example, for users, the manufacturing CO2 emissions will come under, as user's perspective, scope 3. When it comes to operational losses, you have 2 categories. Number 1, it's joule losses, and number 2 is an SF6 leakage losses. So in terms of joule losses, if the user produce their own energy, then it comes under scope 1. If in case the user purchased the power from the external supplier, then it will come under as scope 2. Whereas the SF6 leakage losses will come under scope 1 of the user. Also, the end of the life emissions will also fall under the scope 1. So this gives the detailed overview of which kind of CO2 emissions fall under which category for a user, so that he can take the decision to limit these CO2 emissions from his perspective. And just as an additional information, in case if you consider instead of SF6 GIS, if you consider a blue GIS, which is an SF6 free switchgear from Siemens, and if in case the user uses only the green electricity, then the complete operational losses is almost close to 0. In the end-of-life scenarios, we will get the information about recyclability of the mentioned switchgear based on the Gabi tool. As you can see, depending upon the available recycling processes, up to 96% of the switchgear is recyclable, making the product one of the most sustainable products in terms of resource efficiency. And just want to give you some more information. All the Siemens Type 2 EPDs will show you or gives you the perspective that the Siemens products are committed to be sustainable in terms of decarbonization, detoxification, and dematerialization, and they all are created or designed under robust eco-design philosophy. And very often we get this question, can we use the EPDs of a similar product to compare the CO2 footprint? The answer is when both EPDs that are under comparison use exactly the same conditions and the same scenario, then yes, otherwise it is not recommended. The reason is the CO2 emissions values change drastically based on the assumptions and the use case scenarios, which Laurent has just explained. And I will show here how much differences you can see between the different assumptions. For example, if you take consider this operational losses scenario, and if you consider at 30% of the load, 30 years of lifetime, and an Austrian grid source, and then compare it to 70% of the load, 40% of the lifetime, and German grid source, then you see there is a jump of almost 22 times higher CO2 emissions of the switchgear, of the exact same switchgear during the operation stages. So we think it shows clearly that the operation emissions are so much dependent on the site conditions that the use of EPD alone does not give an complete details about the CO2 emissions, and we cannot use this as a reporting. So one of the solutions what we think is better is to have a dynamic CO2 calculator with an actual input of the switchgear load and energy source, CO2 equivalent intensity, etc. So you can see here an example of a Siemens, from the Siemens using our energy monitoring software, NX Power Monitor, where you have a dashboard available showing the scope 1 and 2 of your substation, which we are planning to make this feature available to the customers from the coming April. So I think with this slide, we are concluding the presentation.